Example problem number 4. Okay, we are given a circuit that looks like this, and then the expression for the voltage. Okay, a voltage is being applied to the circuit. That voltage expression is given. Similarly, a current is going into the terminals of the circuit. The expression for that current is given. The question really is looking in to the circuit, what is the Z or what is the impedance? Okay, in order to do that, the problem is straightforward, the solution is straightforward. In order to find the impedance, okay, all we have to do is to divide, okay, we're going to divide voltage by current, okay. So we know V equals to IR, R equals to V over I. R is the resistance, Z is the impedance, Z is the impedance. Okay, so let's begin with VG. VG is 300 cosine 5000 t 5000 pi t plus 78 degrees. The first thing I want to do is to convert this to polar form, which is 300 angle 78 degrees. That's the phasor, right? The 300 angle 78 degrees is the angle. That's VG. Similarly, little ig is 6 sine 5000 pi t plus 123 degrees. Okay, and this should be amperes, I suppose. This guy, the one above is volts. This guy is really amperes. Good. So this guy is volts. This guy is amperes. Now it is not in cosine form, so the first thing we are going to do is to write this sign as cosine of everything else is the same plus 123 degrees minus 90 degrees. Remember, um, cosine of theta minus 90 degrees is sine theta. So sine theta is cosine of number minus 90 degrees. Okay, that's the idea that we are using here. Now, here we can write IG, the phasor transformation of IG is 6 angle 33 degrees. Okay, now we have VG and IG. Okay, in order to find Z, all we have to do is to VG over IG. Therefore, this 300 angle 78 degrees divided by 6 angle 33 degrees. Now, division is pretty easy in polar form. Just divide the magnitudes. So 300 by 6 will give me 50, and then subtract. Okay, and simply subtract the angles when you're doing a division. Okay, so the answer therefore is 300 by 6, which is 50 angle 45 degrees, is it? 45 degrees, angle 45 degrees. Okay, so that is the impedance. Now you are asked to write it in rectangular form. Write it in rectangular form. So Z in rectangular form is 50 cosine 45 degrees plus J 50 sine 45 degrees, which will amount to 35.355 plus J 35.355 ohms, because these are in amperes and volts. Impedance is always in ohms. That's the first part of the problem. Let's box this. Now the second part of the problem is, what is the second part of the problem? This guy is A. Now comes B. Okay. The question is, by how much time t in milliseconds is the current and voltage out of phase? Okay. Remember this. The phase angle of the voltage is 78 degrees. Oops. The phase angle of the voltage is 78 degrees. Okay. The phase angle of the current is 33 degrees. So the phase difference between V and I is 78. The phase of the voltage minus the phase of the current. Okay. 78 minus 33 degrees, which comes to 45 degrees total. 45 degrees is the phase difference between the voltage and current. But we are asked to calculate the phase difference in terms of time, t. Okay? The idea that we use is, if each of the two waves, voltage and current, are out of phase by 360 degrees, that amounts to one time period. So this is, okay, this is your voltage, let's say, and then let me duplicate this and put it in a different color. Okay, if this is the case, they're out of sync by 180 degrees. If this guy was like that, then each of these are out of phase by one full time period. Okay, eventually they are in phase when it is 360 degrees. So 360 degrees corresponds to a time difference of one time period. Therefore, 45 degrees corresponds to 45 over 360 times t period, which is 1/8 of the given time, how much ever that value is given to be. Okay, time period. We can calculate time period from the frequency, right? We know the frequency. I'm going to leave that as an exercise for you. You see, here there is this 2 pi f. Okay, so you're probably looking at a frequency. Okay, let me write it as frequency is 1 over time period. Okay, therefore a frequency right there. If you do this, 1 over frequency, that is going to be 1 over 8 multiplied by 1 over 2 pi over 5000 pi, because frequency omega is 2 pi over t. Therefore, t is the same as 1 over f, is the same as 2 pi over omega. Okay, that's what I'm doing here, 2 pi over omega. Okay, omega is given to be 5000. Okay, omega is given to be 5000 like that. Okay, So therefore, and the time difference or the voltage and current are out of phase by 45 degrees, which is the same as 45 degrees by 360 into t, which is going to be 50 microseconds. Okay, so t, the voltage and current, are out of phase by 50 microseconds. Okay, that's it. So all we have done is to divide the voltage by current in its polar form. Okay, and then in order to calculate the phase difference between V and I in terms of milliseconds, all we had to do was to plug in the value for F so we can get an expression for T. Once we have T, we know that the voltage and current are really out of sync by 45 degrees, out of phase by 45 degrees. Therefore, we can do the simple math to see that the time difference or the voltage and current are out of phase by 50 microseconds.